Okay. Write down the name of the article, force and momentum. Force and momentum. Now, first topic we'll talk about addition of forces basically. Force. Push or pull. Force is defined as push or pull. That changes the state of an object. That changes the state of an object.
Okay.
Force is defined as push or pull that changes the state of an object. Clear? Okay. Now force is also defined as product of mass and acceleration. F is equal to ma. So force is also defined as product of mass and acceleration. Product of mass and acceleration. Product of mass and acceleration. Then we talk about unit. Yeah. Okay, we can discuss at the end. Force unit is mass unit is kg, acceleration is meter per second square. So kg meter per second square. It is also called as Newton. Newton. So unit of force is basic Newton. Clear? Next. Addition of forces. Addition of forces. Addition of forces. Now see, as we know, force is a vector quantity. Force is a vector quantity. That means addition of force is on the basis of vector addition or vector subtraction law. So what is vector addition law? So this law states that suppose we have an object. Suppose we have an object and whose mass is m, and we are applying a force, say F1 is equal to 10 Newton towards right hand side. F2 is acting 5 Newton in the same direction. If I want to find total force that is acting on this object, on this body, which is nothing but the addition of these two forces. So F is equal to F1 plus F2. F is equal to F1 plus F2, F1 plus F2. So 10 plus 5, that is 15 Newton. 15 Newton.
Yeah.
In the direction of right hand side. Right hand side. So we normally add the forces and the direction is always in the direction of greater force. In this particular case, it is acting towards the right hand side.
Yeah.
If you take an example, number 2, suppose we have an object whose mass is m and say force F1 is acting say 10 Newton towards the right hand side. F2 is acting 8 Newton towards left hand side. 8 Newton towards left hand side. If I ask you to find the total force, So total force, that is also called as net force.
Yeah, I see.
Net force. So it is F1 minus F2, which is nothing but 10 minus 8, that comes out to be 2 Newton. 2 Newton. It is important to note that the direction, so direction is always towards the greater force. So direction is from left to right. So this is the direction. From left to right.
Right.
Clear? So this is how we calculate force. In this particular example, if you observe, so this astronaut is applying a force of 60 Newton towards right hand side. Similarly, 50 Newton is acting towards left hand side. If I want to find the total force, so total force is what? 60 minus 50. That is how much? 10 Newton. And what is the direction? Towards a greater force. That is towards right hand side. Towards right hand side. Any doubt?
Yeah.
Okay. Now, suppose if I take an object whose mass is m. So we have an object whose mass is m. Now it is important to note that the force is not acting in the horizontal or vertical direction. The force is acting at an angle of 30 degree. The force is acting at an angle of 30 degree with the horizontal. With the horizontal. So in this particular case, what we do, we generally resolve this force. This is called as resolution. 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 Resolution means break the force into two components, along x-axis and along y-axis. Along x-axis and along y-axis. This is called as resolution. Can you break this force along x-axis and y-axis and tell me the component?
That is a component.
Yeah. In order to resolve the force, what we do, observe this condition. Suppose we have vector A. We want to split this vector along x-axis as well as y-axis. So this is x-axis and we have y-axis. So this is y-axis. We have x-axis and y-axis.
Yeah.
If this angle is given theta degree, this is theta degree. So you can move this y-axis here. We have 90 degree.
Mm.
Now, apply the formula cos theta. What is cos theta? Cos theta. First apply sin theta. Perpendicular over on hypotenuse. So what is perpendicular? Y. Hypotenuse is A. So y is equal to A sin theta. Y is equal to A sin
Okay.
theta. If I apply cos theta, cos theta, cos theta. Cos theta is base upon hypotenuse. Cos theta is base upon hypotenuse. Base is x. Hypotenuse is A. So x is equal to A cos theta. X is equal to A cos theta. X is equal to A cos theta. That means this component x is A cos theta. And what is y, value of y? A sin theta.
This idea.
Y is A sin theta. So I will tell you a trick. Basically in exam there is no, we don't have time to derive this. So the trick says that from where the angle is formed, that component is cos theta. I repeat, from where the angle is formed, that particular component is cos theta. If you observe this component, this component, this one. So angle is always found anti-clockwise. Anti-clockwise. So this component will be cos theta. So it will be if I take it as say f. So it will be f cos 30 degree, and perpendicular to will be f sine 30 degree. This is the component. Similarly, suppose a vector is given, f is equal to 5 Newton, and the angle is given as say 30 degree. Can you find the factor? Can you resolve the force?
Yeah. So, the x-axis will be 5 cos 30, and the y-axis will be 5 sin 30. Okay.
Yeah. So from where the angle is found, that particular component is cos theta. So as I have told you, angle is always found in the anti-clockwise direction. So this component will be f cos 30 degree, and the perpendicular to it will be f sine 30 degree. So this is how we generally find the resolution of vector. This is how we resolve vectors. Any doubt? Okay. Now similarly, if I ask you to draw the resultant force. So if you observe, we have a particle or a mass. So astronaut 1 is applying a force of 16 Newton, while A is applying 50, B is applying 60. See the directions. So direction is basically a right angle triangle, na? So this is the right angle. This is right angle. Yeah. So net force will be along the. This is the resultant. This is the resultant basically. Any doubt?
Yeah. No.
Now you can easily find the resultant of it. Okay? Pythagoras. Right? Or see, in this particular case, you can easily solve. There is no issue at all.
Yeah.
Root of 50 square plus 60 square, right?
Yeah.
See. Root of x is what? Root of 50 square plus 60 square. Solve. Tell me the answer. How much you are getting? Yeah, what is your answer?
78.1.
78.1 Newton. 78.1 Newton is the required answer. Next one. Do this one. Find the resultant force. Find the resultant force.
Resultant force will be 5.3.
Resultant force will be 5.83 Newton. 5.83 Newton. Okay, fine. Next. Just give me 1 sec. Yeah. Now you can easily find the force. Now next article is called as free body diagram, FBD. Free body diagram or free block diagram, FBD.
Okay.
So basically what do you mean by free body diagram? So suppose we have a surface and you place an object here. You place an object here. Can you tell me how many forces are acting?
Gravity.
Yeah, first one is weight, more precise weight. So weight is mg, W is equal to mg mass into kg. Now, the next one, the force that is acting perpendicular to the weight, it is called as normal reaction. This force is called as normal reaction. It is represented by letter N or sometime by R. Normal reaction. Normal reaction. Now, any other forces acting on this body? Right now, no. We have only two forces. Clear? And the body is at rest basically. So we are not considering any other friction force or other forces into consideration. We are just assuming the body is at rest condition. So we have only two forces. First one is the weight that is acting downward, and the second one is the normal reaction that is acting upward in the perpendicular direction. Now it is important to note that free body diagram means you need to separate these two bodies. Like this. What we have done, we have separated this object and we are marking the force that is acting on this body. So the force that is acting along positive y-axis, so I will take it as positive, while the force that is acting downward, I will take it as negative. So summation of Fy equal to 0. Summation of Fy is equal to 0. Summation means what? Sum of all the forces. Sum of all the forces. Sum of all the forces acting along y-axis.
Yeah.
Sum of all the forces acting along y-axis. Clear? Is equal to 0. So normal force positive, weight negative, equal to 0. So N is equal to mg. N is equal to mg. Any doubt? So this concept is called as free block diagram, FBD, free block diagram. We can take an example of an inclined wedge also. Suppose we have inclined wedge. So this is inclined wedge. This is inclined wedge.
Yeah.
Let us assume the angle to be theta d. Okay. Now, how many forces are acting on this object? Suppose this object is not sliding, it is at rest condition. Or you can take an example of sliding also. Okay. Suppose this body is sliding. How many forces are acting on this object? So first one is the weight. Weight. Yeah. Weight. Yeah. So weight is mg. Weight is mg. W is equal to m into g. Then next one. Yeah. Next one is the normal reaction force.
Yeah.
Normal reaction force that is acting perpendicular to the surface. Normal reaction always act perpendicular to the surface. It is important to note that normal reaction always act perpendicular to the surface.
Okay.
Normal reaction always act perpendicular to the surface. Clear? Pardon?
This is friction.
Yeah.
Friction.
Then we have friction, right? Now first we need to balance this normal reaction. See, it is not balanced at all. So this angle is theta degree. So this component will be mg cos theta and perpendicular component will be mg sin theta. Am I clear? Mg cos theta, mg sin theta.
Okay.
Then we have friction. Friction. So friction will act upward. So this is friction basically.
Yeah.
This is friction. Friction. Clear? Okay. Now we need to resolve. We need to find fx and fy. So summation of fx is equal to 0. Summation of fy equal to 0. So first we'll try to find summation of fy is equal to 0, right? Sum of all the forces acting along y-axis. So how many forces are acting along y-axis? If you observe this force. So this force, let me change the ink. Yeah. So we have this force, this one, and this force, no? This force. These two forces are acting in the y-axis direction. Clear?
Yeah. Yeah.
Okay. So I will just equate this. Yeah. So n is acting upward, positive, minus mg cos theta equal to 0. So n is equal to mg cos theta. Mg cos theta. N is equal to mg cos theta. Any doubt? Any doubt? No. Similarly, along x-axis. So summation of fx is equal to ma. Please note, we are equating force is equal to ma. Why? Because the body is moving.
Okay.
Body is sliding. If the body is at rest condition, we always equate to 0.
Okay.
If the body is at rest condition, we always equate summation of force equal to 0. If the body is moving, sliding, we equate it equal to ma. Now,
Okay.
how many forces we have? So we have friction force that is acting upward. So friction force minus mg sin theta equal to ma. Equal to ma. Fs minus mg sin theta equal to ma. Static friction minus mg sin theta equal to ma. I hope concept is clear.
So let's try to.
Yeah. Please make the note of it.
Yeah.
Yeah, copied.
One second. Yeah, done.
Chalo, good. Next one. No, this one. Calculate the force. Calculate the force required to balance.
Won't F be 40?
Pardon?
Won't F just be 40 to balance?
Yeah. All these four questions I will give you for your homework.
Okay, hello.
Now, next article is Newton's first law of motion. Newton's first law of motion. First law of motion. Inertia. Inertia. Inertia is basically a state. Okay. So we have inertia of rest, inertia of motion, and inertia of direction. I repeat, inertia of rest, inertia of motion, inertia of direction. So if an object is at rest, it will remain at rest unless and until we apply some force to move an object. That is called as inertia of rest. Inertia of motion, if an object is in motion, it will remain in motion unless and until you apply some force to stop the body. That is inertia of motion. Inertia of direction, a body is moving in a fixed direction, it will not change its direction by itself unless and until you change the body or you change the direction of an object. That is called as inertia of direction. So there are three types of inertia: inertia of rest, inertia of motion, inertia of direction. Clear? So inertia means state of resistance to change, or you can also define as resistance to change. Resistance to change. It is called as inertia. Resistance to change. That is inertia. I hope concept is clear.
It is.
Next article is basically friction. 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 Friction means opposing force. It is basically opposing force. It always acts in opposite direction to that of applied force. Always act in opposite direction to that of applied force. Always act in opposite direction to that of applied force.
Uh,
It always acts in the opposite direction to that of applied force. That we are talking about friction, right? There are three types of force. Then it is a contact force. These are the features for frictions. It is a contact force. That means it comes into picture when two bodies rub together. That is called as contact force. Contact force.
Okay.
So friction is a contact force. It comes into picture when two objects rubs. There is a friction that is emitted. Clear? Next one.
Okay.
There are three types of friction force. First one is called as static friction. Types of friction. Types of friction. First one, static friction. Types of friction. First one, static friction. Static friction. Second one, static friction. Second one is dynamic friction. Dynamic friction. And the third one is called as rolling friction. Rolling friction. I repeat, there are three types of friction: static, dynamic, rolling friction. Static, dynamic, rolling friction. Static friction, when the body is at rest condition. A book lying on a table is an example of static friction. Book is at rest. Book lying on a table. On a table. In static friction, body is at rest. Body is at rest condition. That is called a static friction. Dynamic friction, when the body is in motion. When the body is in motion. When the body is in motion. It is called as dynamic friction.
Okay.
Example, you can take an example, this one. Suppose you are pushing a box, clear, and the box is moving. So when the object moves and the friction that is developed between the surface is called as dynamic friction. Sometimes we also call this as kinetic friction. Dynamic friction is also called as kinetic friction. Kinetic friction. Any doubt? Kinetic friction. And the third one is called as rolling friction. Rolling friction. Rolling friction. Suppose this angle is theta degree. Yeah. So this is an example of rolling friction. When a body rolls or an inclined plane, it is called as rolling friction. Rolling friction. So when a body rolls, on an inclined plane, the friction is called as rolling friction. Rolling friction. Out of these friction, if I talk about the magnitude, so magnitude wise, static friction has greater magnitude.
Okay.
So static friction is greater than kinetic friction. Is greater than rolling friction. Static greater than kinetic greater than rolling friction. Clear? Please make a note of it.
Yeah.
Yes, done.
Okay. Yeah, I'm done.
Okay. Next one. Now into the next article that is called as buoyancy. Buoyancy.
Hmm.
So buoyancy is defined as basically is an upward force. Buoyancy is an upward force. So it acts on an object when an object is immersed in water.
Yeah.
It acts on an object when it is immersed in fluid. When the object is immersed in fluid, it's called buoyancy. Okay. So when we use the term fluid, fluid means any substance that can flow easily. Those are called as fluids. Example.
Okay.
Example of fluid: liquid,
Yeah. Gas.
gas,
Things around this. Around ones.
yeah, those are called as fluids. So this force is always equal to weight of an object. Yeah, weight of the fluid displaced. So buoyant force is always equal to weight of fluid displaced.
Okay.
Weight of fluid displaced. Weight of fluid displaced. Any doubt?
No.
Next we'll talk about air resistance. It is also called as Stokes law. Air resistance. Air resistance. It is also called as Stokes law. Stokes law. So the upward force or the buoyant force is given by Stokes. It is equal to 6 pi neta RV. 6 pi neta RV. 6 pi is basically a constant. 6 pi is constant. Six pi is constant. Neta is called as coefficient of viscosity. Coefficient of viscosity. R R R R is basically the radius. And what is V? V is velocity. V is velocity. So F is equal to 6 pi neta RV is nothing but the buoyant force. Clear?
Okay.
Yeah.
No.
So please write it down.
Yes, sir.
It is important to note this law was given by Stokes, so it is called as Stokes law. Stokes law.
Yes, I'm done.
Done. Any doubt?
No.
No.
Next article is called as terminal velocity. Terminal velocity. So suppose if we drop a ball in a water container. So we have water. This container is filled with water. If you drop a ball in it, so if you drop a ball in it, right? So these are the upthrust force. So this ball will, when you drop a ball, initially the velocity of the ball is very high. But due to upthrust, the velocity will become constant. So the constant velocity with which the body is moving inside the fluid is called as terminal velocity. I repeat, the constant velocity with which the body is moving inside the fluid, in the fluid, is called as terminal velocity. So this constant velocity is called terminal velocity.
Okay, understood.
So the formula for terminal velocity is Vt is equal to 2 by 9 r square rho minus sigma into g by neta. This is the formula. Vt is equal to 2 by 9 r square rho minus sigma into g by neta. R is what? Radius of the ball. G is gravity. Rho is density of an object. Sigma is the density of water. Neta is the coefficient of viscosity. So rho, what is rho? Rho is basically density of an object. What is rho? Density of an object. What is sigma? Density of a liquid. Density of a liquid. G is gravity. Neta, what is neta? Coefficient of viscosity. Neta is basically coefficient of viscosity. Coefficient of viscosity. Neta is coefficient of viscosity. Yes, please make a note of it.
Okay, sir.
Written?
One second.
Okay.